situation, light is going to be reflected off of that flat mirror. It creates an image behind it. This is going to be called a virtual image. The virtual image, it says over here, is going to be formed by rays that appear to be coming from behind that object or the image in the mirror. But that's only because why? It's being reflected back. That's where it looks like it's coming from behind, but that's only because it's reflected back. But they're never there. They're not real. It's a reflection. It's just being reflected back, and it looks like it's there. So here, this is a really good picture. I like this picture because it's a plain flat mirror, nice and smooth. This is the real object right here. This right here we call a virtual image. And it's always going to be looking like it's from the same distance and the same height, the same shape. It looks the same as long as my mirror is a plain flat mirror. Let me give you an example. I do this all the time. I don't know about you. Maybe you do, maybe you don't. Oh, there's a difference. There's a difference if I go like this with my phone and I take a picture of you. That is different, right? Than if I come over here and switch my camera to look at me and take a selfie. Do I want to post that selfie picture when I flip the camera to me and my words on my shirt are backwards? Haven't you done that before? No, you don't want to post that picture. What do you do to the picture before you post it? Flip it, right? So that way your words are the right way. So when you take a selfie like this, what happens is that it's going to get a virtual image. Is that really you? No. It's an image of you. It's a virtual image of you. And when you look in the mirror and you look and you see your image, that's not you in the mirror. That's a virtual image of you. Okay? Now that virtual image is going to look just like you. If I take a selfie at this location, or if I set my camera up and I step back, am I going to look further away if I stepped away from the camera versus close up? That makes sense. I'm not talking about this forehead 0.5 business that some people do. I'm talking about just a regular, I'm going to stand my phone up. I'm not talking about trying to do this so I can try to look skinny or whatever. I'm not adding no filters. I'm just taking a picture. And this picture is going to be a virtual image. But if I go like this and take a picture of you, it's going to be the image. If I go like this, I've got to flip it. Because this image is going to be exactly the same, but it's going to be flipped. Okay, keep that in your mind. It's going to be flipped, which is pretty simple because a lot of us do this. We take selfies and you have to flip the image because your words are flipped on your shirt. So let's go ahead and keep that in your mind on this next part. Like I said, it's really easy cheesy. We've got a little bit of notes and then we're going to get to that worksheet today. We're going to do the whole worksheet. We need to understand it, and I think we need to do it together because it's not an easy worksheet. It says over here that the object distance from the mirror is always going to be equal. Remember how I said, are you going to take a close-up selfie or are you going to stand and you're going to move back 3 feet? Then that means that you're going to look like you're further away. It's going to be equal in the distance. It's going to be a virtual image that's going to be appearing behind the mirror. For an example, if a 6-foot person is standing 2 feet from a plain flat mirror, again, I can't use that word enough, a flat mirror, then the virtual fake image is going to be a 6-foot person, 2 feet. They're not going to look like they're 6 feet. No, they're going to look like they're 2 feet from the mirror. And this image is going to be what we call a virtual image. But I cannot stress enough, it's a plain flat. And the reason why I can't stress enough, because your worksheet, one side is a plain flat mirror, the other side is going to be a convex lens. There's a difference between those. Okay? Right now, we're still talking about plain flats. I'm going to go to convex and concave in just a moment. It says here that if an object is reflected smaller or further away, haven't you looked through a car rear view mirror? Or what about those side mirrors in your car when you look outside the door? Those are not a flat mirror. Those are not flat mirrors. Those are concaved or convex. And because of that, it's going to cause the image to look smaller, upside down, tiny, bigger, because they're not flat mirrors. Now, let's continue to look at this flat mirror, and we're going to just do it super easy cheesy, and then we're going to move on to concaved and convex. It says here, ray diagrams. If you're going to use we're going to use simple geometric shapes to locate an image that is formed by a mirror. That's what ray diagrams are. Or, let's add extra words in, or a lens. Okay? Because we're going to do this with lenses that are curved and mirrors that are flat. But this situation, let's look at a flat mirror. Okay, so you're looking at a mirror this morning. Alrighty, let's pretend you're looking at your shirt and it has a letter and you're standing in front of the mirror and the shirt has a big letter R. A big letter R. That's it. Why? I don't know why, but your shirt just has this big old giant letter R. Now this, you are standing in front of the mirror. You are the real object that's in front of the mirror. The mirror is going to produce I can't stress enough, a fake virtual, obviously it's not real, image that will be the same size. Okay? It's going to be the same size in distance, as in how far away from the mirror, and as in height and width. I mean, gosh, I wish every time I looked at a mirror I was skinnier. I mean, I'm not. It actually shows me how big I am. So the same thing over here. My image, what did I say about that selfie camera? Every time I take a selfie, it's going to be flipped. My image will always be flipped. So over here, I'm going to go ahead and I'm just going to wing it. The true way is you would get a ruler out to do it. And you would do all of this hot mess over here. I don't want to do that. This is easy cheesy. Let's go ahead and just draw. Use your eyes and do the best to draw a flipped letter R. Hey, that's pretty good. That R is pretty good. Look at that. Not bad, Miss Munson. It's a flipped letter R. Just like if you took a selfie. But remember, this is a flat mirror. Let's go ahead and scroll the page all the way to the bottom. Look at the bottom of the notes right here. What does it say? It says this word, convex mirrors. Okay, well, on convex mirrors, this is where it's going to be an outward curve shape. oops, I misspelled it, shape. Right here in the middle, it's kind of bigger, fatter, bulgy in the middle. It's called a convex. This can be in a mirror or it could be in a lens. Let me give you an example. Some people, we have bad vision and we have to wear convex or concave lenses to correct our vision. Now, when it comes to convex lenses, there's a couple of things that we need to, or convex mirrors, we need to know. They will always produce a smaller image. Look at that baseball. It looks like it's further away and smaller than the actual size of the baseball. It will cause the light to be diverged. It will diverge the light. It will make a virtual image. And the image, look at the baseball in the picture, is going to be upright. Okay, when you're ready, flip the page. Now these are mirrors. Our worksheet is going to have to do with convex lenses. And we will get into convex lenses in our notes more on Thursday. We're almost done with notes. Now the convex mirrors, it says here, light rays are going to be diverged. That's what we said on the previous page. And the object will be smaller. That's some key notes. When it comes to convex mirrors looks like this. It's bulgy at the ends and it's skinny in the middle. For those of you who wear glasses, stop for a moment. Are your glasses concave or are they convex? What shape are your glasses? I know that your glasses are not flat. Can I tell you what type of glasses are flat? The people who go to that like Claire's or somewhere's at the mall and they think it's cute, like, oh, I have perfect good vision, but I'm going to put these fake glasses. Like, whatever. Okay, I have to buy my stupid glasses and whatever. Those lenses and those fake glasses are flat. But for those of us who wear glasses, I didn't wear mine today. My glasses are a little thick. My vision is bad, right? Are you convex or are you concave lenses? So stop for a moment if you wear glasses. A concave is going to have an inward curve. Kind of like this. It's skinny in the middle. It's going to have an inward curve. Now, concave are going to cause a real image, okay? It's still an image. It's not real, okay? It's still an image. It's going to be upright or inverted. Look at these two mirrors of the penguin. This penguin is correct, and this one is inverted or upside down. It will cause it to be either enlarged or it can be reduced. Oh, I hate those. That means that you don't really know, tomato, tomato, which one is it? I don't know. You have to wait till you can see the image. But you can look at those images of those penguins, and you can see one is closer, one's bigger, one's smaller. I'm done with notes today. On Thursday, I will have my lenses and mirrors out for you to grab and play with. Please just be careful and try not to break them. That's it, or scratch them. But let's go ahead and let's flip to this worksheet. I know it says homework number 1. You know what? It's not going to be homework number 1. I made a decision today. We're just going to do it in class because we need the practice. You will have this on quiz and test. It will even be one of the questions on semester exams. Okay? But let's go ahead and let's take a glance at this. Let's do this side. You need, and do you remember the note card that was up in the beginning of class? You need a green pen, you need a red pen, you need a ruler, and you need a pen or a pencil. Blue or black, I don't care. It's up to you. Okay? So this is what we need. A blue, black, green, and red. Okay? Now, we come across convex and concave lenses and mirrors all the time. We wear glasses. We drive. Those mirrors are going to be convex and concaved. You look at a mirror in the morning before you get ready. This is something that you're exposed to. You're just probably not familiar with it or the vocab words. Not a problem. Let's do this. Here's what we're going to do. Go ahead, and first thing is I want you to look, and I'm going to zoom out so you can see the whole worksheet for me. But when it comes to this side of the worksheet, this and this right here is going to be a flat mirror. It's not concaved, it's not convex, it's flat. And what happens? I'm going to have a real object that exists. So this side is going to be my real object. Real object. We need to understand what those words are. And on the other side, I'm going to produce an image. An image. This side is going to be my image. Right? Now, if this is a plain flat mirror, remember how I said, you're going to come over here and you're going to do a selfie? What happens when you take a selfie picture? It's always flipped. So to produce an image from a real object on a plain flat mirror, it is going to be flipped. So imagine, yes, you're supposed to use a ruler. I don't have that kind of time. There you go. That's pretty good. I know it's off a little bit. I'm not perfect, and I'm not using the mirrors. Don't get mad at me. But isn't that what it's going to produce? Yeah, a flipped image. Let's do it again. Easy cheesy. Let's go ahead, and you're going to try to draw it about the same size and about the same distance. No, I'm a little lazy. I'm not going to use a ruler, but give or take, you know what I'm trying to say. Makes sense. It's going to be a flipped image. Isn't this easy cheesy? That's how fast I'm going to move past plain flat mirrors. But the next one, when you're ready, flip the page. The next one actually does take some practice to understand how to draw. Okay? So on the next one, let's first talk about a few things. Number one, I want to make sure that we know that we're going to use 3 different colors. I'm going to come over here, and I'm going to write this in for you. Line number 1 is going to be green for this whole worksheet, and it's always going to be my top line. Okay? So later on, when you go back to look at this worksheet to actually do the real homework number 1, because this is not homework number 1 no more. We're going to add this to our notes later on. Line number 2 is going to be red, and we're going to do this in the same colors as we continue. You can tell I have a whole bucket of pens because this is something that I do every single year in the same colors. This is always going to be located at the bottom. It will make sense once we start doing this. Line number 3. Again, I want to use a thin pen, not a thick marker. Line number 3 is going to be some type of pen or pencil. I'm going to say blue or black. And it's actually located in the middle. Don't get me wrong. You can do your lines in whatever order you want. And you can do them all in pencil later on if you want. Me personally, I have too much science to kind of keep order and straight in my head, so I like to color code things, especially after I left college of the mainland when I was younger. I went to UTMB. When I went to UTMB first to a medical school, I color coded. Everything that had to do with blood was red. Everything that had to do with viruses was a certain color. Everything that had to do with bacteria, for me, personally, was green. I thought green like, I got a stomachache, bacteria. So I color-coded things so that way I can keep things straight in my head. I still do that at the hospital to this day. All right? I have red, blue, and black pens in my pocket at all times at the hospital, personally. It helps me organize my thoughts. So that's the reason why I'm doing this in colors. Now, the next thing that I want to talk about is the actual thing over here. This is what we're drawing, but they only have 2 lines, Miss Munson. You're right. I added a 3rd line to help organize my thoughts a little bit better. What I do want to say is that when it comes to this picture over here, this dot is called the focal point. You're going to hear focal point again later on next week, okay? We have a big F, a little f, and we're going to get to a math equation. You're going to need these F's next week on the math equation. The drawing is for us to understand the math later. The next thing that you need to know is that this right here is going to be a convex lens. This is not a mirror, this is a lens. So that means that the light is going to pass through it, not reflect. Does that make sense? That's why my lines are going all the way through the other side. Makes sense? This is a lens like your glasses. The next thing you need to understand for this worksheet is that this object right here is going to be, quote unquote, a faked image, but this is going to be my image that's produced. That is going to be my image, and this right here is actually considered to be the object, the real thing, okay? So I want to make sure that we understand. The next thing I want to do is I want to stop for a moment, and I want you to understand what these words are. So do you know what the word upright means? It's standing up. The word inverted means upside down. Do you see how they check the word inverted? Look at my image. It's upside down. It's inverted. The next one, look between the word enlarged or reduced, meaning is it bigger or smaller? Look at this image. This image compared to the real object is smaller. It's reduced. And, oh, this one's important. Is it a real object or is it a virtual object? Well, it depends. Line number 1 and number 3 must touch. If line 1 and 3 touches, it's going to be a real object. If line 1 and 3 do not touch, it's a virtual object. Okay? So let me go ahead and write that over here. I'm going to just circle this. And I'm going to say right here, line number 1 and number 3 touch. They only have line 1 and 3. They're not doing line 2. That's okay. No worries. If line 1 and 3 touch, it's real. Equals real. If line number 1 and number 3 do not touch, it's going to be virtual. Again, this may not make a lot of sense yet. We still have more notes that we need to cover, okay? The next thing that I want to tell you is this is the reason why I think it's a little cool to go ahead and open up cow eyes, because this is actually inside of our eyes. So this right here, you need to pretend that this is my eyes looking at this object. So right here, this is my eye, and inside of my eye, I have this lens. The problem is, sometimes we're born with a little bit of issue, like maybe it's called astigmatism. Maybe our, muscles in our eye that holds our eye together are a little weak. And when our muscles get a little weak, or maybe our eyes just shaped a little differently. But the problem is we are not focusing the actual image in the correct spot or location. So when we dissect the eye, you're going to see exactly where the retina is. If you personally are not forming the image located on the retina in the back of your eye, then in that case, the image is going to be a little fuzzy, or you can't see very clear, and you need glasses to help clear and make the image nice and at the exact location. Okay, so let's go ahead and start this. We're going to always start with green. Green is our first line. How we do this is we are going to have the light shine from the top of the object to the middle of the lens. And we are going to connect top to top. So top to top, at the middle of the lens, I'm going to stop drawing my line. So I'm going to start from here to here. I'm going to try to draw it as straight as possible. Why am I going to stop the line, which I stopped really good at the middle of the lens? Because the moment that it hits the middle is where the light goes, and it's going to refract and bend. Because now it's passing through a second medium. And when it refracts, it's going to always bend and touch the focal point. So now, make it bend and touch the focal point from here to here. Pretty good, but I've been doing it all day for 18 years. That's pretty good. Me personally, because later on you're going to have your own homework, I'm going to call this line number 1. Just in case if you forget. Line number 2, I said, hey guys, let's do that in red, just so that way we're all on the same page. Line number 2 is always going to start from the top of the object. Light will pass through it and go to the bottom of the middle of the lens, and it's going to stop. So it's going to go from here to about here, stop at the middle of the lens. And you can see, I literally stopped drawing it once I hit the middle of the lens. Why is that? Because when light passes from one medium, air, to a second medium, a lens, it's going to refract and bend. And now I'm going to bend it to go straight. As straight as I can make it. There. I'm going to call that line number 2. And number 2, does that make sense? The top line, the bottom line. Let's go ahead and do the middle line. The middle line is line number 3. I'm just going to use a black pen. And what I'm going to do is I'm going to cause my line to go from the top of my object to the middle of my lens and keep going straight through. So from the top to the middle of my lens and keep going straight through. That's a little hard. Dang, that's pretty good. My goal is to have all 3 lines or rays of light to converge to one point. Okay? Let's do it again. I'm going to go ahead and call that line number 3. Number 3 is in the middle. It goes through the middle of the lens. Line number 1, line number 2, and line number 3. Do it again. Go to number 2. Start off with green. You're going to go from the top of the object to the middle of the top of the lens. You're going to stop. There. Then I'm going to refract and bend and go through the focal point. And there it does. It bends and goes through the focal point. Again, remember that focal point is going to come in handy when we do our DI and DO math later on. Okay, line number 1, let's label it number 1. Line number 2, for those of you who feel like you can keep going, keep going. Don't wait for me. If you're that awesomeness, go for it. Okay, I need to refract, bend, and I'm going to call that line number 2. And then line 3 goes through the middle of the lens from the top of the object. There it goes. Line number 3. And your goal is at the back end to have all 3 of them connect at the same spot. It doesn't work out perfect. Our major concern is line 1 and 3. Those have to. Those are important. Line 2, not so important. That's okay. We don't want to say that too loud. Line 2 might get his feelings hurt. Go again. Do it again. All the way through number 5. If you got a problem, you're confused, then stop. Don't do it. Wait till I get there. But if you got it, then go for it. Line 1. Number 1 is at the top. Number 2 is at the bottom. Don't forget, go to the middle and stop, and that's when refraction is going to occur, which means it's going to bend. And do you see, even though it bends, after it bends, what does it do? It travels in a straight line, because light travels in a straight line. I can't say that enough, unless we're looking at time space with big objects and black holes. We're going to let that go.
And then things get really fun.
I know. I would love, maybe right before I die, stick me into a black hole. Let me go there. My last breath. I want to warp time space. Maybe I'll find me a new multiverse somewhere else. Remember, the green line and black line, those are our important ones. The red line, try your best. And this doesn't come out so hot. That's the reason why we got to practice, and this cannot be counted as homework number 1. We really need to practice. Even my number 3 is not coming out good. Logan, you having problems with 4 and 5? Are you good?
No, I finished them all.
Were you able to draw all 3 lines on 4 and 5 perfectly?
Yeah.
Even the red?
Yeah.
Even the number 3? And did they touch?
No.
Okay, gotcha. Continue with your lines. Because it's gonna look a little, right, it's gonna look a little funny. I agree, like Logan said on number 4 and number 5. Make sure it touches the middle here. Line number 1. Line number 2 is at the bottom. Again, it's the black line and green line that we really want to make sure that are done as good as possible. The red is not so important. Try your best. Line number 2. Oh, no, Miss Munson. Number 1, number 2, and number 3. Snap, I can draw it, but they're not even touching on number 4. The same thing's gonna happen on your number 5. Don't leave until you get all of them drawn in, because you're not taking my pens with you. I know. I appreciate it. I actually put your matte pencils into existence over here. Oh yeah, you come across any more at home before you bring them. I know you still have younger siblings, right? You're the oldest, aren't you? Okay, I thought so, yeah. Yep. Is that why you're going so close to school here? Are you doing it for mom and dad, or no?
Didn't feel like going out of state.
Yeah.
Too expensive.
Oh God, it is. I agree.
Besides, this way my parents said they'd buy me a house.
Buy you a what?
House.
Oh, okay.
Me and my sister are both going to U of H.
Okay.
Buying a house in downtown.
So that way,
Miles away.
God, it was kind of creepy when they had that one person there.
Partly because
Uh-huh.
housing on campus is half the price of the house.
Yeah, it's insane.
And they
U of
said
H.
If they could sell the house after we left, then they'd make money.
Okay. Man, they should have purchased this a long time ago. I bought a house in Lamarck over 30 years ago. I think I paid $18,000. And it came with a full lot on the side that was already fenced in. Yeah, it's ridiculous. Now, what I rented out for, it's crazy. I know. I wish I would have bought a whole bunch more. Okay, so here we go. First thing, were you able to answer them all? Number 1, did you answer it? What's the correct answer? Upright inverted. What do you mean, Miss Munson? This is what I mean. Step 2. Now that you did your drawing, wait a minute. We need to draw our actual image. So let's look over here. Your image is located where line 1 and 3 connect and touch. Do you see how line 1 and 3 touch right here together? Draw in your image. It's going to be flipped. Do you see how line 1 and 3 touch? The tip of it touch here. The tip of it must touch here. Let's do it again. Line 1 and 3, the tip of it touch here. Line 1 and 3, the tip of it touch right here. The line 1 and 3, look at line 1 and 3. Even though the red is way off, this is where we actually connect. Line 1 and 3 connect over here. This is where it actually is drawn. But do you see number 4, number 5, line 1 and 3 do not touch. So it does not produce an image. We call that virtual. We call it virtual, and the image is none. There is none. It's none. Write it in. There is none. We call it a virtual image. Can I tell you what happens? In your brain, sometimes you may not see the full image or the full picture, but your brain will connect the rest of the dots and make a virtual fake image that's not even there. The image is none. It's not there, but your brain is so smart that it can connect the dots and make a virtual image and you see the full picture that fast. Pretty cool. That is pretty cool. Let's go ahead and go back up to number 1. Let's look at number 1. Number 1 is what we call inverted, and number 1 is actually a reduced. Look at that. It's smaller. It's baby size, and it's real. Number 2 is inverted. Look, it's what we call a real image because line 1 and 3 touch, but do not check off reduced or enlarged. If you actually got a ruler, it's really the same size. So this is where your ruler comes in handy. This is the same size. Number 3, it is inverted upside down, it is enlarged, and it is real. Now the whole worksheet is done. Have a